I want to offer a personal thank you to everyone for showing up for an 8 a.m. session on the last day of Summit. The night after various parties, the block parties, account teams and their debauchery. I'm sure everyone here is bright-eyed and bushy-tailed and ready to go. And if not, that's okay. This is going to be the best presentation at Summit, period. So you are really members of a very exclusive club. And after this, it'll be an experience like none other, and you'll be able to tell all your friends that they missed something great.
Yeah. If you're coming to see ExxonMobil speak, unfortunately the Exxon guys had to leave a day early, so they couldn't make the session. So Josh and I are subbing in as the pseudo Exxon. So if you're mad that the Exxon guys didn't come, you guys can just go and back to the show floor. But otherwise, we'll do the best we can here.
After I just played it up, you're going to tell them to leave?
It'll be amazing.
It's going to be great. This is going to be our rough agenda. We're going to loosely follow this, but there will be some breaks in the presentation just to give us some flow. We're probably not going to use all 45 minutes or an hour or whatever we have. So feel free to ask questions, stop us anytime. This can be more interactive and conversational. It is intended to be more thought-provoking than actual do this, do that, right? In addition, this is kind of built and framed from the standpoint of some of you are probably IT professionals working in the IT space. You may be working at industrial companies, manufacturing companies, oil and gas, automotive, food and bev, blah, blah, blah. We're going to walk through some of the things you're already seeing or probably going to see shortly and explain why it's happening. And talk about how, as kind of these two worlds collide, what steps you can take and how you should take them to ensure that you have a successful strategy and a successful approach for integrating and bringing resources and objects that you're not typically used to under management and treating them like you do things that exist in a cloud or a data center.
Hey, just to get a feel for the audience so we can maybe customize a little bit, how many people consider yourselves either OT people or at least very familiar with operations technology? Anybody in the room? Oh, look at that. Sweet. Okay, that's good. Cool. That's unusual for our sessions here.
We were going to role play up here. That sounds really inappropriate when I say it out loud. We were going to role play. I was going to be the IT professional, and then Dave was going to be the OT professional, and then we were going to yell at each other and walk out and see just like some shock factor, but we'll probably skip that. Okay, so let's do some quick introductions. I think I'm up first. I'm not going to read all those words because I can't really read. I hate professional headshots with a burning passion. I never look good in them, so anytime people ask for a picture of me, I always put up a picture of one of my corgis. I am Red Hat's industrial edge architect, so my main focus is how we bring Red Hat tools, technologies, and processes into the OT space. I've had a long and storied career of getting thrown out of jobs, both at Red Hat and previous to Red Hat. I've done everything from plant management to building industrial control panels to being an enterprise architect for a Fortune 100 company. I've had a few different roles here at Red Hat, and I finally settled on one that I actually liked, which is this one, and it's been a lot of fun so far.
And I'm Dave Rapini. I keep saying new to Red Hat, but it's been a year now, so people don't like me saying new. So I came from Rockwell Automation, so I had 27 years in industrial automation, where my last job there was I ran the Plant PX business, which is their distributed control system. So building controllers, designing HMIs, and the interfaces and how that work was what my team basically did at Rockwell. I came to Red Hat because of what we're about to talk about here, which is this transition of IT, OT, and how they're getting married together. I'm very excited about where that's going in the technology, and I saw an opportunity here. My job here is to actually help Red Hat with their strategy on how to move into that industrial space and have products and a portfolio and sales into that area.
Okay, next up we're going to do some level setting. We're going to just walk through what some of the definitions are for those who are familiar, bear with us. For those of you who aren't familiar with some of the terms, we're going to go through and kind of talk through what these terms are and where they can be generally found in the business. If you guys didn't hear, it is the AI Red Hat Summit AI. That's the experience this year. Did someone do the thing? Someone was going to go with a clicker and count how many times they said AI in the keynotes. Did anybody do that? Okay, I wanted to get an official count on that. It was a lot. I figured we would get in on that, ride the craze. So I went and I actually asked ChatGPT for definitions of some of these terms just to see what it would kick back to me. And it actually did a pretty decent job. We're not going to read through the whole definition, but I think it's important to call out a couple of key points when we talk about these definitions because they help us define the focus and the imperative around these various areas, right? Now, to level set, they're both bases of technology. They both do things, whether physical or virtual, right? So there's commonality. But if you read through this, IT typically is found in the business and the business enterprise context. So it exists in clouds and data centers. Its focus is on running a business. So running transactions, routing data, providing services for internal and external consumption. That's really the objective of what IT is and does. IT also has seen a lot of sprawl over the last 20 to 30 years. So we've integrated and included a ton of different technologies, platforms, approaches to computing, so on and so forth. So it's a very wide-ranging area, and it can be very challenging to manage. What I will say, though, is IT has found a lot of ways to really do effective orchestration and management, a lot of them popping up in the last 5 to 10 years. I then went back to ChatGPT, and I asked it, what's OT? And it gave me actually a fairly similar answer at the beginning, but it did diverge, which I thought was pretty accurate. It's primarily focused on running physical devices and physical processes. So the commonality does exist. It's still probably some level of compute, but it's not going to necessarily exist in a data center or a cloud. It's going to exist a lot closer to the things that it's actually running and controlling, and it's going to be very, very focused on the operational state of that. In addition, over the last, I would say, 10 years, OT has also taken on a data flavor. This has been represented by added functionality in DCSs and SCADA systems. Our OT systems generate tons and tons and tons of data. Right now, a lot of it just gets routed into a historian and never looked at again. But that data is actually very valuable, and we actually have been storing it for a while. If I take has anybody here seen the onion slide from Red Hat? It kind of walks through the various areas of compute that Red Hat focuses on. Yeah, maybe? Okay. If not, don't worry, you're not missing anything, I promise. I really don't care for that slide. But if I change some of the graphics and I lay it out like this, Red Hat has really been playing in, you can call it kind of 5 pillars, 5 columns of compute. On, what would that be, your right would be your kind of core areas, so data centers and clouds, hybrid cloud situations. This is something that we talk a lot about. We've had a big push into metro and access edge. This is typically predominantly in the telco space. So you can think of your favorite cell phone provider. You can think of wireless communication. Red Hat's actually very big in the telecommunications space, both in the United States and North America and globally. And over the last, I would say, 5 years, we've been pushing further out to what we call the premise and device edge. So if we have these 5 pillars, 5 areas of compute, Red Hat has traditionally lived, I would say, the most heavily in the enterprise core, right, in your hybrid cloud. And we've done a little bit at the metro edge. We're pretty decently big at the access edge, but it isn't necessarily IT, that's more telco. And I would be willing to bet if you're in the IT space, you're probably managing or running some systems that exist in a bunch of remote sites. You can think of retail stores, remote offices, branch offices, sales offices, things like that. You may even have sites, or you may have systems in things like manufacturing plants and oil refineries. But that's probably not the main focus for you, right? That's probably not the majority of your systems. If I flip this a bit and I ask, where does OT live? It's going to live very heavily at the device edge and at the premise edge. So it's almost always exists at a site. It is contained by the 4 walls of the site. It lives behind that site's firewall, and it probably doesn't have anything above and beyond that it relies on. It's perfectly capable of functioning, even if the site were to fall off of the face of the earth, right? It would just continue to go. If I overlay the two, you'll see that our locations of deployment and our location of operations are pretty much divided. We have a little bit of consternation right here at the premise edge where we may have some overlap, but in a very traditional model, in the model that was, I would say, very prevalent up until a couple years ago and even into now for some organizations, these two worlds basically didn't talk to each other, and they lived separate, and they didn't really have a reason because they weren't consuming each other's services and they never really ran into each other. Let's talk about a couple of the key differences here. I asked the AI again to kick out a simple word cloud for the focuses of IT. You will see that this one right here, innovation, is probably the biggest one in the word cloud, and that is primarily being driven by the explosive growth and focus on AI, both gen and predictive. So that kind of falls, it categorized that under the innovation title. But you can see here security, compliance, scalability, delivery speed. These are all things that have been focuses of IT for forever, right? Our objectives have been deliver fast, deliver reliably for the business, allow for innovation if we need to, scale our services so that our customers can continue to consume them, and if possible, scale to a point where we can run the business extremely effectively, but also limit our costs, right? If I flip the question and ask it, give me a word cloud for OT, reliability actually pops up. In fact, you won't find innovation in this word cloud. You will only find things that we typically associate with OT. Reliability, consistency, maintainability, these are very, very common mantras in the OT space. We also here can see some things around security. That's become a huge focus in OT. Traditionally, we just pretended that these systems were secure because we put them behind a firewall, and that solves every problem, right? Except now they're becoming connected, and we find out they're all full of holes. In addition, you'll see something in here called safety. This is a concept that IT's typically not super familiar with. In the OT world, when we say safety, we mean physical safety. We mean the safety of human beings, of machinery, and of sites. It means that these are physical systems. They light up, they move, they spin, they make noise, they generate heat, so on and so forth. And the humans that have to interact with them are a priority. Whether we think they are or not, they actually are a priority. And OSHA would be very mad if we didn't think of it that way. It would seem that we have some differences, and we do. We have some different areas of focus, but there are some commonalities. There are words that go across both word clouds. I can point out security, scalability, efficiency. These are universal concepts, IT, OT. And something I really want to point out here, just because we have differences in our focuses between IT and OT, that doesn't mean we're incompatible. It just means we have to work a little bit harder to speak the same language, and it means we have to work a little bit harder to build effective systems that are viable in both the IT and the OT space. All right, so why? Why is all this happening? What's going on? Why are these two worlds attempting to collide now? And what is really driving it? Well, a lot of it's being driven by adoption of generic compute. So on your left-hand side of the slide, you'll see very traditional OT devices. These are called PLCs, programmable logic controllers. These are things that typically get a bunch of wires run into them, and they control the speed of drives, they open and close valves, so on and so forth, right? These are very industrial, very embedded devices. They are not typically treated as normal IT assets. They are not amalgamous to a virtual machine or a small form factor device. They're very, very bespoke, and they do one thing, and they do it very well. On the right-hand side is more commodity hardware. These are not servers, per se. They're not large systems that we put into a rack and shove into a data center, but they are fairly open, interoperable platforms. So these are typically running x86 chips or ARM chips, which we have some familiarity with in the IT world. They typically run a standard operating system. I really like it when they run RHEL, spoiler alert. I like it when they run OpenShift, but they also run Windows and they run other distributions of Linux. Things that are more, I'll say amalgamous, or more common, more relatable to the IT folks, right? I would say about 10, 15 years ago, you would never find commoditized hardware in a plant. We never bought it, never had a reason for it, never put it anywhere. In fact, I would say a bunch of these product lines that you see nowadays from some of the suppliers in the space, you can think of your OnLogix, your Avantex, Lenovo, Dell, et cetera, those product lines didn't even really exist. But there has been this explosive growth and adoption of these over the years. And so now when you walk into a factory, even a more traditional factory, I guarantee you'll find some general compute devices. Sometimes they'll look like this, sometimes they're a little bit bigger, sometimes they're a little bit smaller, but the intention is all the same. This is really being driven by data. At the end of the day, when we say terms like IT/OT convergence and Industry 4.0, really what those are speaking to is the ability to consume, route, contextualize, and ultimately act on the vast amounts of data that we have been generating in the OT space for years. I hit on this earlier, I'll hit on it again. A lot of the data has been kind of sitting, it's been at rest, it's been not doing much of anything. It is uncontextualized, it is hard to access. This is no longer a sustainable model. If we are to innovate, if we are to drive the OT space forward, if we are to start adopting or gaining capabilities around further or higher level functionality, think about predictive AI, we have to have a handle on our data. The first real thing, the first real foray into this is something that I bet everybody in here has heard of. It's an IoT gateway. Everybody heard of that? Yeah? What does an IoT gateway do? It sits somewhere, it gathers data from one side, and it throws it somewhere else. That's it. That's really the imperative of that device. A lot of these devices act in that very capacity, right? They are IoT gateways. That's kind of the first foray of IT entering the OT space, so that we can understand and slurp up our data.
So if you guys are OT familiar, you're familiar with a lot of the general problem statements that we're talking through, that we're trying to help solve here. So the first one, and Josh kind of hinted around a little bit about it, was lack of interoperability. And if you're an OT system integrator and you show up on a plant site, you typically have disparate systems, disparate architectures that you need to merge and get working together and make commonality. Making that happen usually requires a lot of custom code. Inevitably, 3 years later when somebody does an upgrade, you're no longer around, that custom code needs to be managed and maintained. It's just extremely expensive to do that best-in-class system integration. And Josh touched a little bit on fixed function, and I can't tell you how many times I've been in plants where I want to add something to the control system, and I've got this perfectly good industrial computer there that's now called a PLC. And what really makes a PLC a PLC, it's really just an industrial computer with a very specific piece of firmware and application running upon it, right? But it is very fixed function. It may have USB ports and things like that, but you can't just plug a camera into it if you need a vision system added, or if you want to add a printer or do some type of ANSI code out of it. You can't just do that easily. So you require additional pieces of hardware. So they're very fixed function, and they don't have a lot of flexibility in what you do with them. They're really hard to upgrade. I will say one of my favorite stories, about a year and a half ago, I was in a plant on the East Coast, and I'm not going to name the customer, but they were still running Windows NT on the facility. So literally, they had Windows NT running on the plant floor. They're disconnected. They're like, it's not broken. It works. I know it's hard for us to manage and keep it up, but in general, it just worked. So they had no reason to invest. Upgrading to new modern operating systems really gave them no value as far as what they're producing, how much manufacturing they're producing, and they were just comfortable running that, which was, their operators knew how to use it. Everybody knew how to run it. It's very unusual for us. So it's because that upgrade costs are extremely high, and a lot of that custom code I mentioned before, when you do those upgrades, the custom code tends to break. It's just expensive to manage. Downtime on upgrades is very expensive, and a lot of the things that the IT guys have gotten comfortable with is being able to do live updates without having system reboots and system crashes. You don't have that in the OT as much. Most of the time, it's a shutdown when you're doing an upgrade or a firmware patch or an upgrade to the software, which is very expensive. There's heavy pressure on production, and that's really a big area of convergence between the IT/OT industries. So most plant managers every year get new quotas. Next year, you need to produce 3% more material or 5% more material. And by the way, you don't get more capacity. We're not expanding, the plant. We're not giving you more staff, but we still want you to squeeze 5% more out of your production. So how do they get that? most of the time they look at optimizing the current infrastructure using things like AI, using things like predictive maintenance, so they can predict downtime before it happens and plan for it and make sure that it doesn't happen and disrupt production. So a lot of those things are very familiar with IT, and it's driving a lot of the AI stuff and the analytics and the predictive maintenance things down onto the plant floor that we're used to. This last one is really a learning curve problem. A lot of the technologies on OT are very OT-centric, and most of the people coming out of college don't have that training, don't have that education. It's getting harder and harder and harder to find skilled workers that know how to do that kind of thing, that kind of work. But a lot of the IT technologies, there's plenty of training in that. There's a huge mass of people like us, or like you, that know how to do a lot of the IT technologies. So being able to morph some of those together and have that commonality is definitely a great thing for the OT departments to help them with their staffing problems. And the great thing about all of these problem statements is many of these the OT departments have solved 10 years ago. So a lot of those technologies that solve a lot of these challenges already exist, and they already have installed bases, and it's not like it's version 1.0, so it helps with the OT's aversion to risk management, right? Another big driver, Josh touched a little bit on connectivity. When I talked about IT-OT convergence in my previous job 10 years ago, we talked about IT-OT convergence as, oh look, we have Ethernet on the plant floor now. Ta-da, we've done IT-OT convergence. And that was a thing. And sometimes the IT departments managed those networks, sometimes they didn't. But that connectivity continues to grow. It used to be, SneakerNet was the thing. It was literally clipboards, people would write data down, they pass it up, and some data entry person would, type it into a database or a spreadsheet so it could get into the IT world. But that connectivity is becoming more and more prevalent, again, to help with those competitive needs globally to get that extra efficiency out of the infrastructure and the architecture. There's also a challenge in that security area that Josh talked about a little bit as well. As that connectivity continues to grow and continues to expand, having those things become more and more secure gets more and more challenging. And when you look at this picture, how many IT guys or people in this room recognize those network interfaces, those networks? Anybody recognize a lot of those? A few of them? So those network interfaces are prevalent in industrial automation. They are actual protocols that are living down on the plant floor, and there's tons of that installed base today, and that's still a connective point. And there are points of ingress into that infrastructure. And if you go to something like, I think it was maybe 2006, NSA, National Security Advisory, then Homeland Security, Division of Homeland Security, finally decided to start looking at industrial automation as a major vulnerability point for our ecosystem and our infrastructure. And when they started looking at that ecosystem, they realized how little cybersecurity is actually available down on that layer. They've relied on things like obscurity and disconnected nature of elements. I can remember when we first started getting a lot more connectivity at Rockwell Automation, we had tools that would just go out and request, controllers respond, just to find auto connect and find them on the network. You could get on the internet and actually have that thing launched, and people's frickin' controllers would respond, all over the country, right? You'd see these guys that didn't have any front end on them, and they'd just get controllers just responding across the globe, which was just horrifying. So that type of thing is something where IT really has a good play here. There's a lot of open standards now that are really driving this change. You look at Industry 4.0, NMR, ISA has a whole bunch of standards. Open Process Automation is a big user initiative that's driving that openness. And what they're really driving for is more of a commodity-based, open source, open platform, standards-based solutions. And what that means is customers can now pick best in class for products that they want to install on the OT space, and they'll just work together because they followed an open standard, an understanding of a standard. And a lot of the connectivity is driven by a lot of this infrastructure as well, right? So Nomura has a great idea of standardizing interfaces on sensors and instrumentation. So they have a standardized interface on a flow meter, and that flow meter has a common interface. But when you connect it to the internet or connect it up to the Internet of Things, it has an interface there as well that's well defined. So it makes that connection into the IT and OT space, much cleaner. So if you have got some familiarity with OT, you've got some familiarity with how you do an upgrade in an infrastructure. And I just put this slide in here just to kind of give you an idea of the how challenging some of this content is. So let's take an example of a controller, and I want to upgrade a controller to a newer version that's got a patch in it to repair a security vulnerability. Today, the workflow for that is you send out a guy with a USB drive to the field, and he goes out and transitions that controller to program mode. He uploads all of the working runtime data that happens to be on it for the current work in progress, so he doesn't lose the stuff working in progress. He burns the new firmware onto the device. He has to modify the program into the new version of software that runs on that firmware, so he modifies the program up to where it needs to be, re-downloads that program, then he manually restores the original data, that was that runtime data, into that device, and then puts it back into run mode. And he does that 1,000 times on 1,000 controllers in a plant as he's doing this patch, and that's a manual process. So clearly you can see that that's just ripe for IT interfaces to do some automation of that task to alleviate a lot of that pressure. All you.
So Dave was hitting on this. If I take our word cloud and I put some of our keywords, focuses back on, you can see that the IoT gateways, the commodity hardware that have been reaching into this are also converging with some of the urgency that OT knows it has, right? So this example of a manual firmware upgrade process is a perfect example. It's clearly something in IT we've been able to upgrade the firmware on servers in bulk for years, right? We've pretty much figured out how to do that. We've been able to automate it, and we've removed the necessity for you to have maintenance weekends where we take all the system administrators, we shove them in the data center, we lock the doors, and we don't let them out until they've upgraded everything, right? We've learned processes and we've started consuming technologies and tools that allow us to just do that remotely and do it over time and non-impactful to the business. Coupled with that are our Trojan horses, if you will, our IoT gateways. Again, these are more like IT devices than they are like OT devices. And thus, IT has treated them like IT devices. We'll update their firmware remotely, we'll run updates whenever necessary. We have a high degree of responsibility for the security of the devices. If there's a zero-day vulnerability on them and Red Hat puts out a patch, we're rolling that sucker out really fast, right? That's the intention. It's not that we don't care about the impact, but we understand the ramifications if we don't take some of these processes and some of these practices and push them out to devices that don't exist in our data centers, right? It's generally not a good time for anybody. Just because we don't align doesn't mean that we can't consume practices across the aisle, right? The other thing that's been really kind of interesting to see is that OT has really grown up. It's no longer living in our basement. It's got a job, it shaved, got a haircut, got a job, and it's moving out into its own apartment. Is this analogy, am I pushing it too far? These purpose-built closed-loop systems and devices still definitely exist today. I'm not downplaying that in any way. But the supporting and supervisory systems that really enable running these devices at scale, those have really graduated to look a lot more like IT applications. A lot of times they simply live on some IT light resources, so even all the way up to servers at the site itself. But a lot of them are becoming very disconnected and very, I'll say, flexible in where they can be deployed and still maintain the ability to manage a site. I think we're moving away from deploying individual supervisory systems at every single site and starting to kind of elevate those to a more centralized location and have them manage many sites. For those of you in IT, you're thinking, okay, move from distributed to central. We did that like 20 some years ago. We did it into a data center, and then after that, we threw it into a cloud. Yeah, that's correct. So OT's kind of reached that same point, just took a couple extra years. If I put our compute locations back up, you can see that the lines are now all over the place, and that the barrier between where we run these applications and the compute that powers them is really kind of broken down. You're going to find IT and OT applications, devices, technologies, and processes running kind of all over, existing in lots of different areas, and really starting to properly converge. All right, we're going to get into some recommendations and best practices. Again, these are going to be given from the perspective of you being in IT and now being asked to start managing some of these OT things. Spoiler alert, I'm not going to show you code, I'm not going to show you Ansible playbooks, we're not going to do that because it's a far more in-depth conversation. In fact, if we had 6 hours, we probably still couldn't cover all of the content that could be talked about there. But we are going to talk about some of the main common or best practices or some of the mindsets you can adopt when you go to start managing these assets that will help make the integration a lot more seamless. I won't say it'll be perfect, but it will be a lot less frustrating, let's say. When we've been working with industrial customers, I'll be honest, networks are probably some of the first areas we talk very heavily about. In plants, for many, many years, we have been buying access layer switches from Cisco, from Meraki, which is now Cisco, from Fortinet, from et cetera, et cetera. These switches have fans in them. And every year, give or take, as they exist in a steel mill, not that I've seen this example directly, but as they exist in this steel mill, they absorb a ton of dust and who knows what, and then they die because you can't just fill them full of crap and expect them to run forever, right? And then someone runs out to the plant with a new one, replaces it, and spends about 2 weeks figuring out what the configuration of that switch was. Because we didn't use any automation or practices to build it the last time, we sent a guy out there with a laptop and a serial cable. Not a very good process. In the data center, we've pretty much all agreed that networks are simply code. Yes, there are switches and routers and firewalls and physical devices, but the way that we define and the way that we enforce our networks is all through automation and all through code, right? This is actually a very, very, very beneficial thing for OT to start adopting, and some of our OT customers have started doing it because they see real value in it. That switch replacement time goes from 2 weeks down to minutes, right? As soon as the switch is there and powered, we can hit it with automation, and it is acting in the exact same capacity as what it was. In addition, firewalls are quite a challenge in the OT space. We're very, very programmatic about what traffic we allow northbound, southbound, left, right. Managing the multitude of rules that need to exist is something that we've struggled with for years. However, in the data center, we got that, right? We did that. That sounds easy. We can do that. You want 10,000 firewall rules? We don't care. You want to do it across 1,000 different firewalls at 1,000 different sites? Easy. We have automation for that, right? So this is a very, very interesting area where a lot of OT customers are starting to converge and agree with IT and say, yes, we can treat these as very modern, automatable things. Our network that powers this whole place really can be something we can manage effectively, and we don't need to constantly be impacted by downtime.
And shameless plug, at 11:30, Rockwell Automation has a tangible version of this that they're going to be talking through how some of that automation can help on that plant floor.
Shameless plug. That is going to be a good session. I'm going to be there. I'll give a bit of a real example, right? If anybody here familiar with the Purdue model? All right, that's more than I expected, actually. So the Purdue model, for those who don't know, we don't have to delve into it. It is a set of rules and guidelines for how to segment a network in an industrial site to provide for some level of security while still allowing systems to communicate where appropriate, right? This looks a lot like segmentation of the network. This looks a lot like, maybe if we were to remap some of the names, we could call this our DMZ, we could call this our app tier, there's our database tier, so on and so forth, right? Again, for our 3-tier applications that exist in the data center, we did this. We automated this, right? We built up processes that support this. I'll say that Ansible is a very, very interesting tool in this space, not because I work for Red Hat, but because of its extensibility. It allows us to talk to lots and lots and lots of different devices, and it's also a very easy tool to consume. Of kind of all of the Red Hat tools that are out there, right, of everything in our product portfolio, Ansible is kind of our favorite gateway drug because it's very easy to read, to understand, to write with. It's very easy to get going with, and it's very easy to get powerful with. Kind of the next frontier, if you will, the next area that OT is starting to really consume and understand is what they consider next generation platforms. In IT, we don't consider these next generation. We're good with Kubernetes, we like Linux, we love containers, we're cool with VMs, all of these things, these concepts, these are all things that we're accustomed to. In OT, some of this is wild and crazy new stuff, and it's something that only the kids are doing, and we don't want to hear about it. But the reality is we adopted Kubernetes at scale for a reason. Lots of organizations jumped on it because of the benefits and because of the operational efficiencies it can provide. In addition, it really does a great job of doing a lot of things for us, kind of out of the box, right? OT is starting to now recognize that maybe the kids are onto something. Maybe those crazy IT kids have something that may be valuable for us in our space. I'll say that the majority aren't totally convinced, but they're getting there, right? They're understanding the efficiencies, and they're starting to understand that, hey, if we can run essentially the summation of the internet's web pages on a platform out of a couple of data centers or clouds, it's probably reliable enough that we could also run a plant, right? And so these next generation adoptions are long running, but they are happening. I am a huge fan of the agile methodology. I'm actually a bigger fan of having the agile mindset, right? When we think about if I say the word agile, everybody here is gonna come up with a different definition. Someone in here is gonna stand up and say, I'm a black belt. We'll talk about it later. But I love some of the key concepts and some of the key enforcements that come out of agile, which is start small and iterate, right? Pick consumable, actionable pieces, break those off, and do a modernization on that. Bring it into existence, bring it into production, make sure it is productive and operates, and then do another one. If necessary, go back and refine, right? I love this mindset. Organizations that attempt to boil the ocean are never successful. In the IT space, we've seen this. Companies often fail at large projects. Anybody here been in the IT department of an organization that's gone through an ERP transformation? Yeah, how did that go for you? Yeah. Happening right now? I'm so sorry about that. Please see me after, I'll buy you a beer. When we have these large projects in IT, and all right, for the IT people here, let's be honest with ourselves, are we good project managers? No, we're terrible project managers. We always have been. The thing that kind of got us out of that jam was being agile and breaking these into consumable chunks and operating in a more, instead of trying to be in a totally holistic, operating a little bit more programmatically. OT loves to operate programmatically. And so this methodology works very well for them because they understand process and procedure very well. So you'll be able to kind of speak the same language when you say, we're going to do X, but X is going to be a very confined small thing, and we'll go from there.
And I can give you an example of that. I know of a project where they're trying to modernize an OT tool to its latest generation, and it's an older project. It was built in the late 90s. It has 3 million lines of C code in this one monolithic application. And instead of doing a nice agile little module at a time, a bunch of little microservices do some at a time, they went after the entire project, and it's holistic. It's 5 years in now, and it's still not actually able to ship. So it's much better to do a much more nimble, agile approach at things like that. And I think the OT guys are learning that quickly. So one of the important things I think that we really want you to take away here is there is a difference between IT and OT. It's not exactly the same, and there is a lot of let's say, non-camaraderie between the two departments. You see a lot of conflict between the two, and a lot of it's because of the priorities of IT and OT that Josh sort of talked about it, what's really different. One of the case studies I like to talk about is one of the large automotives I used to work with, had that IT-OT convergence mindset. They had an Ethernet network down on the plant floor. IT took over the Ethernet network and started managing it, and it was great for a while. And then one day, IT pushed down a new policy onto the switches, unbeknownst to the OT guys, and brought the plant down for about 8 hours before they could recover. And that's, they do one SUV every 90 seconds comes off that line. So that's a lot of production loss. The staff just stood around, so you have an entire shift doing nothing, waiting for the network to come back up while they're trying to figure out what was going on. And what really happened in that infrastructure, when you take something like a flow meter or a small device that's sitting on the plant floor, it's got very limited power capabilities, it's got very limited horsepower, very limited memory. And if it needs to talk to multiple devices on that network, let's say I have a flow meter that needs to talk to 4 different controllers, because 4 different controllers need to know the data from that device. And the rates at which those transmit data, let's say every 3 milliseconds, it has to provide that data to all these different devices. That's a pretty heavy load for a very small device with very limited horsepower. So what a lot of the OT guys have discovered, they found that this thing called multicast that works beautifully. You just build, instead of building 4 different packets to the 4 different devices, you send one packet out, multicast, and the other guys can listen to it out on the network, and it works great, and they did that. The IT pushed down a new policy that limited multicast traffic. Devices sort of worked. They could ping, they could connect, the unicast stuff worked great, but somehow some of the other traffic just stopped working and nobody on the plant floor could figure out why. Because the networks all looked like they were up, everything seemed to be running fine, but they couldn't get past that spot. So the point of that story is, as IT people, we don't necessarily understand a lot of the challenges that the OT guys have had to face and how they've solved those problems with different software or creative solutions that may conflict with our knowledge of what we think is best practice. So it's important that it's not just that the OT guys don't understand the IT technologies. It's very obvious that the IT people don't understand a lot of the OT technologies as well. So I think the big takeaway from this session is it's all about communication to make this interface, this IT-OT convergence actually work. It's about sitting down with the OT guys, sitting down with the IT guys, and making sure you collaborate and before you push out new concepts or new capabilities, help them get through it. Josh kind of hinted around a little bit about the adoption of containerization in Kubernetes. The OT guys have no familiarity with that, and you're going to have a maintenance guy out there at 3 a.m. panicking because he's got a container problem and he can't figure out how to solve it, and that's not in his wheelhouse. So being able to help train them and get them up to speed is going to be very important for us. So it is really about collaboration to make this work. Anything to add?
Thank you.
Okay, with that, are there any questions that anybody wants to give us? Yeah.
Do you have any tips on how to get a seat at the table? With the OT guys, as an IT guy, they kind of view us within our organization as the enemy,
Yeah.
right? And it's been very difficult to penetrate the wall.
Yeah.
Any tips on how?
Yes, bribes.
Okay.
They love bourbon, they love scotch, they love beer. It's one of those. Bribes always work.
It does. But really, joking aside, it is important to try to break down those walls. And I think, honestly, working up the ladder, as uncomfortable as that is, tends to be the best method because you've got a chief security officer somewhere that knows that connectivity is there and that his OT staff may not have the skill sets that you guys provide to the table. So getting that, it's uncomfortable because you have to force the discussion, right? But I've seen that work quite commonly, right? Talk about security vulnerabilities. In fact, at that Rockwell session, we have a lot of discussion about, some of those security vulnerabilities that have been exposed over the years, and just come with that challenge because that connectivity is happening, and that merging of those is happening regardless of whether you're working together or not.
Within our organization that's happening now, they want to get data off of those devices, and there's an IE2000 that separates the OT environment from the IT environment in our world, and everything's netted and out of that.
Yeah.
So you got to break that net, you got to bring those devices online, but you're putting the cart before the horse because there's tremendous risk in doing that, right?
Absolutely, and the real challenge there is the OT guys consider the IT guys idiots, and the IT guys consider the OT guys idiots, right? So that kind of has to be broken down into a more collaborative environment, and I think it's really a management problem at the end of the day. It's unfortunate that it is, but I think it's hard to get. I rarely see the collaboration breaking organically from a grassroots up. Great. Anything else? Wow, you moved. You flinched. What was it? No, go ahead.
Okay, so just to ask, what is your view on access control, particularly the IT customers who control the access to machines and so forth? What is your view on that?
Complicated, long-running. No, I'm kidding. Access control is a complicated topic. IT goes in with the mindset of nobody should log into anything, right? Do everything as much as possible through code and through automated tooling, right? OT, we're not there yet. If I can offer a bit of advice, I would say it's okay to allow for the bending of some of the policies we have in IT around access control to keep an OT site running, right? That's a valuable endeavor, and that's a way to extend the olive branch, right? But what I will say as well is be willing to offer to back it with strong RBAC and identity services, right? So it's one thing to allow people to log in, but it can be made far more secure by offering them the capability to have identities that automatically rotate, or very, very scoped and controlled identities that only have certain permissions or whatever, right? You're going to want to offer them the most, how do I put this, the most succinct way to achieve something secure. They're not necessarily going to care about the details per se, which gives you kind of some freedom and flexibility to say, hey, I'm going to just provide this to you kind of as a service, right? And while they're going to be happy with that, you get the cool part of saying, yes, this is in our general strategy of trust and our strategy of access, right? And we've carved out a specific provision for them to ensure that we keep the business moving.
And that's a horrifying topic, really. Every OT provider, Siemens, ABB, Rockwell, Honeywell, Siemens, they have their own ecosystem and infrastructure on access to what operators can do. They have policy on area-based policies that say, okay, you're an operator, you have the rights to acknowledge alarms, but only acknowledge alarms in this physical area. But you can see alarms in this physical area. They have entire infrastructures that manage that security, that manage that login capability, and it's not tied to much of the IT, login capability. So, it's really a challenge because, they have some basic credential stuff that goes through the IT departments that they tie together, but then all of that local security on what you can do, are you allowed to change a line of code or modify a tag value? Those kinds of things, add an extra layer of complexity to that story. So that's a tough one.
And I'll say I've seen a bunch of organizations attempt to try and wholesale merge those identities. And the challenge they're going to run into, right, is that there isn't a synonymous role that exists in the IT space that represents I'm an operator at these 5 stations, right? That not a thing for us, right? So it's a bit of a challenge. It's a hard topic, honestly. I'm not sure I could give you a quick win on it.
Anything else? Okay, with that, great, thanks.
Good rest of your show.